All right, so welcome back to Emoji Economics YouTube channel. We'll be looking at series and sequences, and specifically, I want to talk about arithmetic progression and geometric progression. But in this class and the one that's going to follow it, we are going to be focusing our attention on arithmetic progression, and then we are going to be solving different types of exercises, different shades of exercises, so that when you come across, an AP question, you will know, okay, this is exactly what I'm supposed to do, right? Because of the different kind of examples that we've discussed in class. Now, normally, when you're watching season movies, okay, you say, okay, have you seen that series? Have you seen that? Oh, I've seen that series. Have you seen Bridgerton? Oh, no, I've not seen Bridgerton. Have you seen this? Have you seen that? Right? So, series is just talking about a number of events, objects, items, or people of similar kind that follow each other or that are coming together, right? But then that is not exactly what it is in math. In mathematics, a series is the sum of the terms in a sequence. A series is the sum of the terms in a sequence, while a sequence is just a list, right, of ordered terms, right? A list of ordered terms. So is an ordered list of all numbers. Like you have a set of numbers following each other in a particular order. Okay, so that is what a sequence is. But then a series is now the sum of all the terms in a given sequence. So we have um, examples here. So for a sequence, 1, 3, 5, 7, 9. So this is a sequence of odd numbers, right? It goes on, you have ellipses, it goes on continually. Then series is now the addition of this odd number sequence. So 1 plus 3 plus 5 plus 7 plus 9 and whatever. We are going to, I think there is a few questions, there are rather a few questions that says, okay, find the, like, maybe first and third terms in a particular sequence. So you have a sequence that is denoted. Before we come to AP here, it says find the third term, find the first and third term in the sequence below. Sequence below. So yeah, the sequence is denoted as 4n plus 3. So there's one that's 4n plus 3. Then there's another one that is what is it? 3n minus 5 divided by 4. 3n minus 5 divided by 4 is not a big deal at all, right? So for this one, the first term, just say when n equals 1, comma. So I'm going to be having 4 into bracket 1 plus 3. That gives you 7. That means the first term in this particular sequence is 7. Then when n equals 3, comma, so 4 into brackets 3 plus 3, that should be 15. Yeah, good. 4 times 3 is 12, 12 plus 3 is 15. Now the same thing here. So when n is 1, so we just do 3 into brackets 1 minus 5 over 4. So it's going to give us minus 2 over 4, which is minus half. Good. Then the next one, the third term, so 3 into bracket 3 minus 5 divided by 4. And this is going to give us 3 times 3 is 9, 9 minus 5 is 4 over 4, which is 1. So if you see questions like this, that is just how to do it. So don't think that it is one very, very big thing. Now, so the thing that we really want to do in this particular lesson, what is AP, arithmetic progression? So it is simply a sequence in which the terms follow each other like in equal measure. So the terms increase in equal measure or they decrease in equal measure. Right. So for example, here is this one. This is an example of an AP series. So how did I know? What is by how much are the numbers here increasing? So it is kind of constant. So 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. So the terms are increasing, at an equal measure. So the difference between the terms is constant, so 2 2 2 2 2 like that. So that is an example of an arithmetic progression. So let's just delve deeper into this and go into these several examples that I want to talk about. So there is a formula for finding the nth term of a particular arithmetic progression, and the formula is un is equal to a plus n minus 1d is simple, right? It's a very simple thing. So what is un? Un denotes the nth term. Then a is the first term in a particular series. Then in a yes, then a is the first term in a particular sequence. Then d is the common difference, right? And then n is the number of terms. Like how does all of this, like how do they apply? Like what is their importance? So now let us look at examples. So we have like 5 examples to talk about, but like let's look at these first two to see how this whole thing works. So solution. I'm giving the AP whatever solution. I'll find the eighth and the nth term. Okay. So to find the eighth term, so that means un there, eighth term. So n is going to be 8, right? Because n is the number of terms, so n is going to be like 8 terms. So then that means our formula is going to be u8, right? The eighth term, that's what we are looking for. U8 into bracket, then the first term a plus 8 minus 1, then the common difference. The question already gave us the a started from 9, so 9 is going to be our first term. Then our common difference is 3. 12 minus 9 is 3, 15 minus 12 is 3, 18 minus 15 is 3, on and on like that. So we can use that to find our eighth term. So this is going to be equal to 9 plus 7 multiplied by 3. Our eighth term is 30. 7 times 3, 21, 21 plus 9, 30. Finish. All right. Just want to be sure. Okay. Now next, it says calculate the nth term. So like we are not given. So this is like I. To get our nth term, so we are just going to have un. Like since we are not given what the nth term is, so just un equals, we have our 8 with 9 plus into brackets nth term n minus 1, a common difference of 3. So our nth term is basically 9 plus 3 into bracket n minus 1. So we can still continue here. So 9 plus 3 times n is 3n. 3 times minus 1 is minus 3. So our nth term equals 9 minus 3 plus 3, and I'm just collecting like terms. And our nth term is 6 plus 3n, which could also be written as 3 into brackets 2 plus n. So that's our nth term. So we are done with that question since we're not given nth term. So this is just what you do. That's how you leave your answer. Then after that, the next thing is the second question that says the 43rd term. So we've been given the 43rd term. But the formula that is going to relate 43rd term to every other thing is going to be u43, right? Equals a plus 43 minus 1, then d. Okay, it says 43rd term has been given as 26, so 26 equals, we don't have a, if that's what 6 you should find, a plus 43 minus 1 is 42, and we're given a common difference of half, Okay, so 26 equals a plus 2 year 1, 2 year 21, 21, then a equals 26 minus 21, a equals 5. So you can see that it is simple. So you could be asked to look for anything. You could be asked to look for this u8, you could be asked to look for n, you could be asked to look for a, you could be asked to look for d. And it is not always this very straightforward, but like the basic concept of arithmetic progression is not difficult. Let's look at the other examples. So let's consider these two questions. It says in an AP, the difference between the 8th and the 4th term is 20. Let's try to like just break it down. So solution. That means there is an 8th term, right? So which means our 8th term, we are going to have u8 equals a plus 8 minus 1d. So u8 is 8 plus 7d. So kind of keep this one somewhere. And then there is a fourth term, u4 equals a plus 4 minus 1d. u4 equals a plus 3d. Question 2. Okay. So it says in an eighth term, the difference between the eighth, in an AP rather, difference between the eighth and the fourth term is 20. Okay, so which one is even bigger? Is it eighth term minus fourth term that is 20, or fourth term minus eighth term that is 20? Because never can tell. Like it could be arithmetic progression could be going, could be reducing continuously from a bigger number to a negative number, negative number, negative number, or from a smaller number to bigger numbers. But I think there's another information there that helps us to know which is the bigger one. It says the eighth term is 1.5 times the fourth term. So that means for this one, it is U8 minus the eighth term minus the fourth term, that is 20. So how do we go about that? Eighth term is A plus 7D, right? Minus the fourth term, A plus 3D equals 20. All right. I think we can kind of, can we, I think something can work here. So A plus 7D minus A, then minus times plus, like be careful, minus times A minus times plus minus 3D equals 20. So you have A minus A, they cancel out. 7D minus 3D is 4D equals 20. Divide by 4, divide by 4, D equals 5. Okay, the first question even said, what is the common difference? So if gotten that common difference to be 5. And then it says, uh, what is the first term of the sequence? The first term of the sequence, that means what is A? So what can we do? So there's another piece of information in the question that says the eighth term is 1.5 times fourth term. So it says eighth term, U8, is 1.5 times whatever the fourth term is. So coming back again, our eighth term is A plus 7D. So A plus 7D is 1.5 times 1.5 times A plus 3D. A plus 3D. But then we already know D, like D is 5. So A plus 7 into bracket 5 equals 1.5 A plus 3 into bracket 5. So A plus 35 into bracket 1.5 into bracket A plus 15. So like small. Let's try to like make this one simpler, which we've done. So A plus 35 equals 1.5 A plus should be 22.5. Like 15 times 1 is 15. 15 times half is 7.5. 20.5. All right, so looking at this, A minus 1.5 A, collecting like terms, come here, equals 22.5 minus 35. This is minus 0.5 A equals minus 12.5. So minus cancels minus. Divide both sides by 0.5. Divide both sides by 0.5. So A gives us 25. So in summary, first term comma difference equals 25 comma 5. So we solved the question successfully. I think that's what it says we should do. First term of the sequence and then the common difference. Now the second question says find the number of terms in an AP. So we'll be looking for n. Yeah. Given the first and the last terms are 13 and minus 23 respectively, where the common difference is minus 2 number 1/4. So let's cook. Not only have I erased the previous solutions, I've also written the fifth question. Well then let's deal with the number 4 first. Find the number of terms in an AP given that it's first and last terms. So remember, UN equals A plus N minus 1D. First and last terms are 13 and minus 23. Now it has given us our last term, right? So which is the formula we're going to use. Our last term is just going to be UN is going to be minus 23 because our first term has been going to be 13. So 13 plus, since we are doing the last term, right? So the last number is going to be what n is representing, right? Is that correct? Yeah. I like the response. So the last number, that's what n is represented. So this is since minus 23 is the last term. So let's say like the eighth term was the last term. Like if we don't know. So just like okay, put the last term that we have here. Then when we solve out, we'll be able to get n to be 8. That's if the eighth item happens to be at the last term. So here we've been given what the last term is, but we're not told the position of that last term. Like so we just leave it as n and minus 1. The common difference has been given as minus 2 number 1 over 4. So we convert that to an improper fraction. We're going to be having minus 9 over 4. So like this. So that's it properly. So from here, minus 23 minus 13. So equals n equals, let me put it this way, minus 9 over 4 and minus 1. So minus this is minus 36, right? Equals minus 9 over 4 and minus 1. So I can cross multiply. Minus 36 multiplied by 4 equals minus 9 and minus 1. And then I still divide both sides by minus 9. By minus 9. So this takes this guy away. This cancels this. 9 here 1, 9 here 4. Multiplied by 4 is 16. So 16 equals n minus 1. So 16 plus 1 equals n. So n is 17. So that means there are 17 terms in this particular sequence, and the 17th term happens to be the last term, then happens to be minus 23. All right, so like we're done. So whenever you're given a question this way, you're given the last term and you're given the first term. So like work with that last term. So you don't know the position of the last term, right? But then you know what the last term is. So put the last term. Let's try to figure out what the position is. And is there another question there? It says find the number of terms in an AP given its first, whatever. So that's all we have to do in that question. Then number 5. Number 5 says that given the following, find the common difference. So we're given this series minus 6, minus 2.5, and so don't let us be tempted into saying minus 2.5 minus minus 6 to give us what the common difference is. It may be like that, it will not be like that. Like so, let us be careful. So find the common difference and the number of terms. So if you look at this, this is like a mathematical expression of the kind of thing that we just did. 71 has been given here to be the last one, so that's like the last term, right? Then minus 6 is our first term. So I think that way it's kind of easy to find our number of terms. So we're using the same approach. Un equals a plus n minus 1 d. So looking at this, we are going to be needing something before we can get our n. For example, this is going to be 71 equals a is minus 6 plus we don't know n minus 1, and we also don't know d. So you might be tempted to just say, okay, why not just do minus 2.5 minus minus 6? We can do that, but like to be sure, like to be very, very sure of what we should do. So let us just do something else. Normally for arithmetic progression, we know that the distance, like the difference between all of the numbers are the same. So you may as well just do minus 2.5 minus minus 6. But let me use that approach. Let me use second term approach. Like since we've been given a second term, right? And then let's use this formula. The second term u2 equals a plus 2 minus 1, then d. u2 is minus 2.5, which is minus 5 over 2. Minus 5 over 2 equals a is minus 6 plus 2 minus 1 is 1 plus d. All right. So looking at this, we can just easily, this one becomes minus 2.5. Then minus 6 comes here to become a plus 6 equals d. So d equals 3.5, which is like 3.5, right? So, and to be honest, we could have just done that because this is the second term. This is the second term. This is the first term. So second term minus first term. So minus 2.5 minus, then this is minus 6. So minus 6. That would have given us minus 2.5 plus 6, which should have given us 3.5. That we got here, 3.5. So like, and this has been proven, so we can just enjoy yourself. Now that our d is 3.5, So what is going to be our n? So we go back to this particular place. So recall 70, that's 71 equals minus 6 plus n minus 1d. So 71 equals 71 plus 6 anyways, no need to stress myself, equals n minus 1, then d is 3.5, which is 7 over 2. 7 over 2. So 77 multiplied by 2 over 7 equals n minus 1. That should not be a problem. Alright, so from here I can just come to this part and say 11 times 2, 22 equals n minus 1. So our n is going to be equal to 23. So we have 23 terms in this particular sequence for number 5. So that's it with the different forms of AP questions on finding the number of terms, find the common difference, find the first term, etc. that I have for you guys. So the next thing we'll be looking at is our assignments, and in our next lesson we'll then begin to talk about some of AP. We are going to discuss different beautiful exercises as well and examples here. Welcome guys. So we have 4 questions on the board. The first says the 28th term of an AP is minus 5. So find its common difference if its first term is 31. That's it. Number 2, find the number of terms in the AP series below: 1, 1/4, 1.5, blah blah, until you have 3.5, which is the last term. And number 3, find the number of terms in an AP given that its first and last terms are A, like letter A, and 37A respectively, and a common difference of 4A. Now number 4, 2 APs have the same first and last terms. The first AP has 21 terms and a common difference of 9. How many terms has the second AP if its common difference is 4? So some of these things are just normal word problems. So if you can interpret the word problem, then you'll be able to solve the question like to a reasonable extent. So thank you for watching. I will see you in the next lesson. Take care.